Sup, welcome back to Algebra 1. Today we're going to be talking about more quadratics. In the last 5 videos we talked about lines, factoring and expanding, and quadratic factoring. This video we're going to be talking about quadratics and solving them, using more tactics and another form of it, and optimization and graphing. It's a lot, but yeah. So first I'm going to be talking about first I'm going to be talking about solving for the roots, right? Remember in the last one, if we factor it, right? So let's say we'd have ax squared plus bx plus c equals 0. What is x? Well, if we were to factor it, we'd get x plus p times nx plus q, right? I know it seems ugly, but yeah, we'd solve for them, use some tactics. It was pretty cool. And that equals 0. Notice that if this equals 0, then either mx plus p equals 0 or nx plus q equals 0. So that means that x equals this linear equation, x equals negative p over m, and x equals negative q over m, or over n. Now, you might notice something. There are two answers. And that's because when you do a cubic equation, so if the highest term was 3 rather than 2 in quadratic, then, or the highest exponent of x is 3 rather than 2, you'd have 3 equations. So what the highest exponent of or in cubic you might have 2 or 1. In this you might have 0 or 1. Or 0, 1, or 2. So now you're always gonna have at least one and a maximum of the highest degree or the highest exponent of x. So yeah, now that's the answer, right? Now I'm gonna talk about how to. So now we talked about the roots, right? Simple, hopefully. Now we're gonna talk about completing the square. Completing the square is a cool tactic and it helps kind of. So when you complete the square, remember a plus b whole squared, right? So what you're kind of gonna do is, so there are 3 forms of a quadratic, right? There's ax squared plus bx plus c. There's factored form, which is, this is standard form, and there's factored form, which is remember mx plus p times nx plus q. And then there's vertex form. Vertex form might seem weird at first, but it's really helpful for optimization. Optimization is where you find the maximum of it, minimum of it, stuff like that. So it's in the form a times x minus h squared plus k. Now, remember what we did? We used reverse engineering, well, reverse math, I guess, but we set this, we knew the form, and we set it equal to this. We're gonna do the same thing here. So if ax squared plus bx plus c is equal to, I'm not gonna use a because it's not always a. Well, I mean, kind of is, but if you can simplify it more. But if you add ax squared plus bx plus c is equal to a times x minus h whole squared plus k, that's equal to a times x squared minus 2xh plus h squared, right? Plus k. which is equal to ax squared minus 2hx plus h squared plus k. I'm gonna put parentheses because this is all together. So now what we can say is that a equals a, right? Simple. So now we're gonna set this equal. So we're gonna have ax squared plus bx plus c, and obviously the coefficients of x squared are the same, and that's the same, and they're already the same, so we don't need to set them equal and solve. So a equals a. We can subtract on both sides. Now the hard part. So negative 2h equals b, and then h squared plus k equals c. Um, Now you also will have, now you want to solve for b and c. So h is equal to negative b over 2. Wait, what am I doing wrong? So, oh yeah, sorry. So you can, so you have like, I need to find more variables. We're gonna say q. No, we already use q. What about w and z? We're gonna use that. So we're gonna have w times zx minus h. Right. Okay. Now we can do this. So we're gonna have and by the way, yeah. Okay. So now we can do this again. Right. I messed that up. I just assumed something dumb. Shouldn't have. But that's equal to. Sorry. No. So z w. Okay. So now we have w times z squared x squared minus 2 z h x plus h squared plus k. So now we have that's equal to w z squared x squared minus 2 w z no w no 2 w z. My 2 and z's look very similar. I know. H x plus w h squared plus k. Okay, so that means that that's equal to ax squared plus bx plus c. Okay, so a is equal to wz squared, b is equal to negative 2wz. Now, wz, because a equals wz squared, that means that, what am I doing wrong? B equals negative 2azh. Okay, now wz squared. Oh wait, no, what? Huh. Don't know what I'm doing wrong. Anyways, yeah, you can expand all that, but like I did with the other, with the many, with the when a is not 1, for factoring, I leave that for an exercise because I'm too lazy to do it. So the key thing with the vertex form is that h equals negative b over 2a, and k equals whatever you get when you plug in, or k, yeah, So, or no, sorry. So yeah, so the maximum. So now I'm going to talk about a little bit about graphing first and why it's called vertex form. So when we have our graph, I think I can like do this. Okay, so when we have our graph, this like, whoa, that's so cool. Nice. Okay, so I keep that at 90 degrees. So now let's say we had a graph, right? And then we were to turn this to 0. Keep our graph right there. So yeah, now we have a graph. Label, of course. Cool. Now this is the x, this is the y. So what you do now is you graph the points, and then when you graph the points of a quadratic, I'm not going to again exercise. Try it, please. You get something either looking like this. Sorry, that's a terrible. Like so if you graph y equals x squared, y equals 0, 0, y equals 0, 1, or 1, 1, then there's 2, 4, then there's 3, 9, right? So 3, 9, and so on. If we plug a negative 1, we get the same things. I mean, if we were to graph it, if we were to plug in the decimal, it won't just be like a line. If we were to plug in the decimals too, it would create a weird shape, and it's called a parabola. It's kind of like curving. Okay. At the bottom, it curves up, apparently. Boom. Lines are straightforward. But parabolas are like a new shape, kind of. Right? If we're talking about y equals negative x squared, we'd get something like, we'd get this, right? Something like this. It'll be flipped over. So now, what this so it's usually a downward. It's usually a downward opening parabola, which is this, when a is negative. It's usually an upward opening parabola when a is positive. Now, the characteristics of this is like, if you, like if you had something like that, and then they cross at these points, that means that x is 0. So these are the roots. Okay, and actually it was a surprisingly good parabola. And then usually they're not all like the same. Like they can be more stretched out, they can be more stretched thin, right? They can be like this, they can be like this, right? Different varieties, many different varieties. So these are the roots, and the stretchiness of it is kind of weird, but it's defined by A and B. Well, B is kind of like a weird thing. It's like this. There's also this, right? It's a lot of weird things, but we're studying this right now. So, the vertex from vertex form is this tip, and if it's an upward opening parabola, we're finding the minimum, and the minimum is a vertex, where it starts to, where it's going down, and all of a sudden it starts going up. With the downward opening parabola, we're looking for the maximum point. So say we had our parabola, not as good, but good enough. Again, roots, right? And then this is the vertex. Cool. So now, solve for the vertex. We don't know that yet, and that's what vertex form is for. And I'm gonna explain that in a minute. But when you get to pre-calc and algebra 2, you learn about something called a focus, which is some point here, and the directrix. And like if like this is some like shape, and like the sun is here, and then it shoots a ray, and then wherever it shoots from, it'll always reflect to that point, which is cool. But that's not in algebra 1. It's actually really complicated. Well, not really complicated, it's just kind of complicated. So what else is there? Yeah, that's basically it about parabolas. So solving for the minimum, maximum, the vertex. Now if we had a times x minus h squared plus k, if x equals h, y equals k, and that's it basically. But we don't. But we need to solve, and to solve for h and k, we can use a and b and c from the original. So negative b over 2a is equal to h, or is equal to the x value of the vertex. I'm gonna say that. So v equals vx comma vy, and then there's some really complicated formula for what's vy, but if you were to simply plug in negative b over 2a, you'd get vy. So we'd have a times negative b over 2a squared plus negative b squared over 2a plus negative bc over 2a is equal to vy. We can expand this, right? That's b squared over 4a squared. So that's b squared over 4a. We can find the common denominator. But you don't have to. You can basically just do it, right? So that's b squared minus 2b squared plus minus 2bc over 4a. And that is negative b squared minus 2bc over 4a, right? And that's equal to vy. But just memorize this if you want to memorize anything. Now, what's next? Talked about roots. Now we need to talk about, so we talked about vertex form. We did not talk about completing the square. Which means getting to vertex form, which we were going to talk about, but then we didn't. Yeah, so also one more thing I want to talk about is, if you were asked, what is the square root of 9? It's 3, obviously. But if you had something like x squared equals 9, x equals 3 squared, both sides, right? But notice, x can also be negative 3. So in this case, there's only one answer. But in this case, x equals 3 and negative 3. And why is that? Well, if we subtract 9 on both sides, we get x squared minus 9 equals 0. That's x squared minus 3 squared. We can use difference of squares, and we get x minus 3 times x plus 3 equals 0. That's also factoring a quadratic, right? With b equal to 0. And that gets us to, and x equals 3 and negative 3. So just remember, if you had the square root of a number, it's just a positive one, or the principal square root. And if you had something squared equals a number, there are always usually two answers. And usually, so now if you add this and we were to square both sides, we get x equals square root of 9, but that notation is already taken by positive square root. What about negative square root? So it's positive and negative. And then I want to write positive square root of 9, comma, negative square root of 9. So they write two things, which is plus minus. They combine them. The plus minus sign, it's just basically saying that, so if you had plus minus 3, that means that you have positive 3 and negative 3 and slash or. So, yeah. I just wanted to talk about that real fast. Now, we're going to talk about completing the square. So, completing the square, I'm not going to use a general form because it gets ugly. Remember, like the p and more variables. So, I'm just going to use an example. So, let's say we have 3x squared. Hold on. Let me think of a good one. So yeah, 3x squared plus 12x plus 19 equals 0. Complete the square. What does completing the square mean? So you know that if you had px plus q squared, that's just p squared q squared plus 2pqx plus q squared. Now we wish, if something was a square, then we'd have the same root twice, right? And so that's where you have something like this. Learn this in Algebra 2, and it's kind of cool. Kind of. That's not a good problem. Give me a second. Okay, that was terrible. Good enough, whatever. So now we notice that the vertex, if the vertex is on the x-intercept, on the x axis, then that means that there's not two roots, right? In this case, there's usually two, but here there's only one. You see that in this at y equals x squared and y equals negative x squared. Here, what it means is that if the vertex is on the x intercept or x axis, then then this root has multiplicity 2, which means it crosses it twice basically. And that means that it has only one root rather than two. Remember, I said it goes up to 2, right? So, nice. Now, completing the square is where we wish it were a square, and we can use that to get the vertex form. So, let's say we had, so if you were to complete the square, then, completing the square would mean doing 3 times x plus n squared, right? I mean, the first one has to be 3, right? Otherwise we have a square root of 3 here. I don't want a square root of 3, so I'm going to keep the 3 outside, so it's okay. So 3 times x plus n whole squared, and plus the rest. But actually use h here. So, and that's equal to 3x squared plus 12x plus 19. So then what this means is that so this extra k is because not every quadratic is a whole square. It's like, it's a square number plus something. So like, let's say we have 13. That's equal to 9 plus 4, right? There's an extra number. So we try to, so 13 is root 13 squared, or we can have the closest one, 9, plus whatever's left, 4. So in this case, if we were to expand, we get 3x squared plus 6xh plus 3h squared plus k equals 3x squared plus 12x plus 19, yeah. Okay, so we cancel those, and what we could do is we could solve for h, or we can solve for k first, or 3x. So we can first solve for 3h squared plus k first, but we want to give, but then we'd have a remainder of, or we'd have a leftover of 5x or something like that, and so we want to give priority to the next thing. So 6x, so it's 6xh. So if 6xh equals 12x, then h equals 2. But if h equals 2, then here we're gonna have 12 plus k equals 19. So k is equal to 7, and that's our leftover. So completing the square is just that. But no, sorry, this doesn't completing the square. That's how you get to vertex form. So that means that this is, so h is 2 and k is 7. Done. Now the next thing we want to do is we want to solve for, now we want to complete the square. Completing the square, so I'm just going to write this is equal to 3 times x plus 2 squared plus 7. Now completing the square is more annoying. To complete the square, what we do is we just subtract 19 on both sides. Then we divide by 3. We just divide by the leading coefficient. So now we get x squared plus 4x equals negative 19 over 3. Then what we do is we complete the square. So what square, or what? So now let's say we had x plus n squared again, h squared equals x squared plus 4x plus some. So actually what we're asking is what's binomial squared. So what do we have to square? X plus h. What do we have to, so what's h? What do we have to square so that we get x squared and 4x as our first two? Well, x plus 2, right? X plus 2 whole squared is the only thing in the form x plus h whole squared that gets us x squared plus 4x, right? X squared, 4x, but then there's a remainder 4, or like leftover 4. So we want to add 4 on both sides of this, so we get x squared plus 4x plus 4 equals negative 19 over 3 plus 12 over 3, which gets us negative 7 over 3. Now this is what's completing the square. We isolate the x, whatever has an x, and then we add something so that it can become a square, right? Equals negative 7 over 3. Now we square root, and we get x is equal to, am I doing something wrong? Yeah, I'm doing, okay, so x is equal to the square root of negative 7 over 3. Or x plus 2 equals that. Subtract 2 on both sides, and we get this as our answer. Now, notice that the square root of a negative number is impossible. In Algebra 2, we use this just to say it's I, but yeah. Because there's there's a lot of stuff, but this one, if you ever have a square root of a negative number, it's impossible, right? So that, in this case, if we have something like this, where it never crosses, right? Or like this, right? It starts, its vertex is somewhere, and then it never crosses it. Because it keeps going up or it keeps going down, so it never crosses it. So that means that that its roots are imaginary or complex, which means that it's the square root of a negative number. So in this case it didn't work, but now we have an idea what to do with completing the square. So now let's try something like let's try another example. Let's say we had let's try something like okay. Let's try 2x squared plus so let me think of an example. Just give me a second. Okay, so maybe this might work. I don't know, but it should hopefully. So we have 2 x squared plus 12x plus 15 equals 0. So what we do is complete the square. So what we first do is we have 2x, so we first subtract by 15. We get 2x squared plus 12x equals negative 15. Divide by the leading coefficient, which is 2, and we get x squared plus 6x equals negative 15 over 2. Wait, hold on. Actually, I'm gonna do minus here. So what if we had minus 15? Okay, so this is positive 15, and this is positive. I just want to make sure that we have positives. So now, what number can we add to both sides so that this side becomes so that the left side becomes a square? Well, I'm tired of just doing the whole thing, so I'm just gonna do a general form. So if we had x plus n whole squared equals x squared plus bx plus c, and we're solving for c, or wait, so obviously b is equal to 2n, right? So so b equals 2n. So that means that if we were to expand this, we get n squared. So c equals n squared. But we're solving for n. We know b, we're just solving for n. So let's say we had bx again plus c. Plus what we're solving for c. So because b equals 2n, right? When we expand this, then n equals b over 2. So we'd have x plus b over 2 whole squared. So we'd add b squared over 4 on both sides, right? So we do x squared plus 6x plus b squared over 4. So we do 9, yeah, plus 9, so which is 6 squared over 4, which is 36 over 4, which is 9, is equal to 15 halves. So now we're gonna do, hold on. So now, oh man. Okay, whatever. So now that means that x plus 3 whole squared equals 15 over 2. That means that x plus 3, if you square root both sides. Oh wait, in the last one, I forgot something. I'm so dumb. So remember, when we square root, hopefully you caught this. You have plus or minus square root of 15 over 2. Please remember that. Plus or minus. Need to remember the plus or minus. If you don't, you have to punch yourself. Okay, now x is equal to negative 3 plus or minus the square root of 15 over 2. Yay! That's the solution. Now, square root of 15 over 2 is some ugly number, so nice. Now, honestly, I'm kind of tired of solving a quadratic by doing so many things. So, what if you just solved a formula? What if we just found a formula for what is x always? Okay, so I'm gonna rewrite it down here. Now we have all the tools to do it. So, oh my god, hold on. What else is there? So we did that. Okay, now we also did this. Cool. So now we just have 2 more things. Okay, so now let's say you had ax squared plus bx plus c equals 0. What is x? That's what we've been solving for these last 2 videos. But let's find a formula using a, b, and c. So obviously we subtract c on both sides, so we get ax squared plus bx plus c equals negative c. Now we divide by a. X squared plus b over 8x equals negative c over a. And now we can use completing the square, right? So we do x squared plus b over 8x. And remember, we add b squared over 4. So in this case, b over 8 squared over 4. So we add b over a squared over 4. And now that is b squared over a squared, or b squared over 4a squared. Oh, frick. Poop. So we have plus b squared over 4a squared, I think. Right? B over b over b squared over 4a. Wait, no, b squared over 4. So b squared over a squared over 4. Okay, yeah, okay. Equals negative c over a plus b squared over 4a squared. Now this side becomes x plus b over 2a whole squared equals, find a common denominator, we get negative c, or negative 4ac over 4a squared plus b squared over 4a squared. Now that's equal to b squared minus 4ac all over 4a squared. Now what we do is we take positive or negative square root of both sides. So we get x plus b over 2a equals, I'm getting kind of excited because it's kind of cool, plus or minus the square root of b squared minus 4ac over 4a squared. That's equal to that's equal to plus or minus square root of b squared minus 4ac all over 2a. Now we subtract b over 2a, and we get x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Right? This is a formula, and I know you can simplify it, which I'm gonna do, so calm down. But we use this a lot. This one, when we have to think harder, we use this. But x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you very much. I mean, we're not done yet, but yeah. I know you guys want to leave, but we're not done yet, so calm down. Now, we have just a few more things. God, we're way beyond the limit. So, let's say we had an ugly solution. So, like, let's say 3 root 2, or like 4 plus or minus this. That's where we use this equation. So, so if one solution of this is a plus or minus b root c times I, where I is the square root of negative 1. So if we had the square root of negative 7/2, because it's not possible, if I equals the square root of negative 1, then this is equal to the square root of 7/2, which is possible, times I. So that's where I comes in, when there's no roots. But if there's no real roots, then there's imaginary and complex roots. So if one solution is a plus this, then the other is a minus that. It's really cool. And yeah, now the next thing I want to talk about is this b squared minus 4ac. So remember on our graph when it was like on the x-intercept. So now what we have is, when it's one root, then that means that b squared minus 4ac equals 0. And you might be asking why that's the case. Well, if b squared minus 4ac equals 0, this all becomes 0, and the only answer is negative b over 2a. I don't want to cross out that beauty. It's so beautiful. Yeah. So now I'm going to talk about Vieta.
How long is this?
45 minutes.
40 minutes. 45 minutes? We need to cut it.
Yeah.
What should I do?
Counting.
No, I'm tired of counting. Let me do something else.
Geometry?
Okay, but there's nothing to teach in geometry.
Let me just finish this video.
Alright, how long? How much longer?
Like a minute. I just need to say Vieta really fast.
Oh god. Okay, chief.
So there's this cool guy named, or girl, or I don't know, named Vieta. Vieta was this human being who came up with a sum of the roots and the product of the roots. Obviously, when a equals 0, then the product equals c, and the sum is usually b. But when a is not 1, then we have a problem. So I'm not gonna prove it. I'll leave it as an exercise, or just search it up or something. But Vieta says that the sum of the roots is this. So sum of roots. It's actually really helpful in competitions, and Vieta can be used in many other when the polynomials have a higher degree. which means that the exponent of x is not 2, but 3 or 4 or 5. And we can use Vieta then, and they're called symmetric sums, but they get a lot more complicated. But right now it's just simple. So the sum of the roots, he or she solved for the sum of the roots and the product of the roots. So the sum of the roots is negative b over a, and the product of the roots is c over a. I'm not going to prove it, but I am going to check it. So if we add up negative b over 2a plus, so if you have negative, so one root is negative b over 2a plus, so one root is negative b over 2a plus the square root of b squared minus 4ac over 2a. This is where we have to use this first one rather than the second one. And then we add negative b over 2a minus square root of b squared minus 4c over 2a. Now, these two cancel, and we get negative 2b over 2a, and that's equal to negative b over a. So that's the sum. We multiply them. I'm not going to do it, but do it as an exercise, and you are going to get c over a. Anyways, this was a really long video. Hope you guys enjoyed. See ya. And I think this concludes Algebra 1. Next time we're going to be talking about Algebra 2. So goodbye. Thank you.